All right. Today, really, we have a couple things. We're going to have wrap up some loose ends. Wednesday will be a work day for you to work on any of the assignments you have. In addition to loose ends, if you have any questions, certainly I'll be glad to address them. All right. We spent a few classes going over examples of using AJAX, using delimited data, XML data, and finally JSON data. I will say that the example probably didn't do XML or JSON justice in the respect that to truly get the benefits of XML or JSON, you'd need a more complex problem. The problem that we went over could have very happily been done using delimited data, and we could have called it a day, you know. And if I was doing that one for real, I would do it with delimited data and not worry about XML or JSON. Yet I was concerned that too big of a JSON or XML example would be intimidating. So what I'm going to do is we'll spend a little bit of time talking about what you would do if you had a more involved JSON or XML example. So we'll spend a little bit of time talking with that. I also want to look at the database example that we had. If you recall, for the last lab, I gave you the script that processes the database. And I think I just gave it to you and we were done with it. All right. Talked a little bit about setting it up. But what I like to do is actually talk about how that works, to give at least an introduction to that. I know some of you have or have not had database experience, so I don't want to go in too much detail. But again, we can at least review the stuff that you have, that you were given. In my mind, really, the most involved piece of AJAX really is the one function, and that is the postback function. And that's the one that probably varies most when we move from JSON to XML to delimited data. Let's look at the examples of those. All right. Because we're going to create the request objects the same way. Doesn't matter what technique we're using, doesn't matter the application. We're going to create the request object this way. We are going to send our request to the server in almost the same way. Again, not depending on, let me rephrase that. Regardless if it's JSON, XML, or delimited, that doesn't matter as far as sending our request to the server. But depending on the particular problem that we're trying to solve, we may come up with this request in a slightly different way. In the example of the quiz, if you recall, we looped through, all right, and got all the answers and put them on the query string. Here we're not looping through. So again, the details of it are going to vary, but still, this is pretty garden variety JavaScript. Chances are what we're doing is we're plucking stuff out of the form. All right. We're concatenating a string that contains our URL and our query string fields. Then we're making that request, setting our callback function, our onReadyStateChange function, and then going and actually making the request. All right? Now, what if you had validation? Well, I kind of did it here. I kind of put a little bit of validation up here where I looked to see if there was a problem. Not really a problem so much, but if there was no data entered, there's no sense in asking the server for a list of words that match it. So I just sort of blank out the dropdown if they do that. If you were going to have validation in here, for example, like you might have for your tuition example, what you could do, call your validation function, get back a Boolean, whether it's true or false, and if it's true, then go ahead and actually make the request. If not, then display your various error messages or whatever you can do. So again, you could easily call your validation function from within this. But this, other than these 3 lines, are pretty constant. I mean, are pretty much not terribly different from other stuff that we've done in JavaScript. On the PHP side, we spend a little bit of time. We'll spend a little bit of time formatting the data. For example, with XML, we'll put the XML tags between things. With delimited data, we'll put the delimiters between things. With JSON, we'll put those delimiters between things. But in my mind, this isn't really radically different from any PHP that we did previously. We're grabbing values from the query string and we're somehow manipulating them. All right? Now, the thing that really is brand new about Ajax compared to the other things that we've done is the callback function. All right? The callback function involves us parsing what we get back. All right? In the case of delimited data, that's going to involve using the split function to split that response text into respective records, then each record into respective fields. That's fairly straightforward. In the case of JSON, what we do is we actually create a JavaScript object wrong one. We actually create a JavaScript object using this line, and then we simply use sort of the dot notation that we've been familiar with, all right, to drill down and get the values that we want. Using some conventions, again, knowing that arrays, you refer to the subscript of the array like this, and the dot notation underneath it. In other words, this would say in our response object, find the word list element sub I, and give me the word attribute for it. So as we loop through, we'll get the word attribute of each of our elements. In the case of the XML example, we use all these methods that exist on the XML DOM to traverse the tree. And we grab, we can grab tags, we can grab children of those tags, and so on down the line. Okay? Now, if this were to get more complicated, what would the impact be? One thing I do want to note, by the way, is for JSON and delimited, you're returning text back, and it's found as part of the response text. With XML, it's the response XML, and you're returning XML data back. If this were to be more complex, that is, if we were to have not data of only one record type, like we have here, each record that we're returning looks the same as a word and it has an index. But if we had more complicated data, like maybe we were returning back book data, and maybe there'd be one row that has general information about the book, a second, third, fourth row that had the authors. And that would vary depending on how many authors the book had. If the book only had one author, there might be one row for author. If it had multiple authors, there'd be one row per author. And then maybe there'd even be a row for the copies of the book that the library had. Maybe the library has a hardcover copy and a paperback copy. So there might be a row for each of the copies. With the limited data, that is tricky. All right, that's where the simplicity of the limited data gets in the way. You actually have to write code to look at each record and determine, is this the start of a new book, or is this, say, an author for the previous book that I looked at, or a copy for the previous book that I looked at. And we'll spare you the ugliness of that code, all right, but that code will get very ugly very quick. And the tough part is you have to write it custom for every situation. The nice thing about the JSON solution and the XML solution is, provided the data is created correctly, there's already built-in mechanisms for you to access that. You don't have to write your own little routine to parse it and piece together all the information about a book. All the information about a book will be encoded in an XML node in XML or in a JSON element. All right? So, how would this get more and more difficult? And let's say we had a case where we had multiple records. Well, in the case of JSON, let me go and run in the case of JSON data, let's imagine if instead of words these were books. All right, and this would be book list, and maybe each one of these would be book title. All right, number of pages. If there were a list of authors, there could be authors square bracket, and inside that square bracket, a list of author names and author birth dates and so on and so forth, author birthplace, and so on, a brief biography of the author, whatever. All right? So there could be just more and more levels deep in here. So this simple element here itself could consist of, could contain rather, an array where there would be additional elements in that. How would you then address that? You'd address that simply by going deeper into your dot notation. Here I'm saying response.wordList sub I word. If this instead were book information, I could say word list sub I, that would pull up the first one in the case of I equals 0, word dot author sub 0, and I could grab the first author from that list. So with this dot notation, I can just go dot deeper, deeper, and deeper as far as I need to go. All right? So if my JSON data look like this, the value of the title. Then I had authors I could do name, Stephen King, and so on. And I could have as many of them as there were authors for that book. Then to refer to that author, I would simply say something like this. Book list sub, since this is the first one, sub 0 dot authors sub 0 dot name. That would give me the first name of the first author of the first book. That would give me the name, rather, of the first author of the first book. Right? Book list sub 0 would point to the first book in that book list array. Authors sub 0 would give me the 0th element of that author's array. Because, again, we're saying that the list of authors is an array, because there could be more than one. And then finally, that name would give me the name of that person. So again, these are all arrays. We can ask the array what the length is. If we wanted to know how many authors there were for a book, How many authors are there for the first book on the list? We could go like this. All right, and get the length. If we want to know how many books there are, we could say this. The point is that JSON, like XML, has built into it these hooks for nesting down as many levels as you need to, whereas delimited data really doesn't have that. Delimited data becomes a pain unless you're dealing with just one type of record, one piece of information per table. In this case, as you can see, we don't. We have book information and we have author information, and there's a relationship between the books and authors. Now, what about XML? All right. Let's consider how the XML for that might look. We might have our book list and then have a book, maybe a title, and so on. Then we can have authors. And so on down the line, with the authors being nested as part of the book and the books being nested as part of the book list. Same data, conceptually, same data structure as this, just implemented in XML. All right? Now, how do we parse that? Well, we parse it in a similar way that we did for our example, except our example really only went one level deep. One thing that you should be aware of, and is important to realize, is that they call these XML data, they often call them trees. All right? Why? Because they have a structure like a tree. What do I mean by a structure like a tree? There's a root or a trunk that comes out, and from that comes branches that are contained in the root. Then from that come other branches. And so on until you get to a leaf. All right. The leaf indicates you can't go any further, right? You're at the end of the branch, at the end of the line. Now, how is XML data like this? Well, like a tree, an XML data has what's called the root node. If you remember, in XHTML, the root node for an XHTML document is the HTML tag. In this example, it would be the book list tag. In our XML dictionary example, it would be our word list tag. And finally, in our last lab, it would be the employees tag. That's a characteristic of a XML data, is there's one root. From that root, then, there can be many children. So we could call this child 0. Remember, we always start numbering with 0. Child 1 and child 2. Child 0, then, itself has children. Child 0, child 1, and so on down the line. Now, build into the XML object, and remember, we get an XML object if our server-side script creates one, provided it's created properly, and the data will come back in the response XML, not response text, then we can use all these different functions to parse that tree. All right? One thing that you should remember about XML, much like with actual trees, and I think sometimes this is described as being like a fractal, or being, I've even heard holographic. All right? The idea of a fractal or a hologram is that a piece of it represents the whole. A piece of a tree represents the whole tree, right? It has the same structure. So, for example, if I came and sawed off this branch right here, that looks like a little tree, right? It has a root. It has 3 branches stemming from it. So each little branch of a tree really has the same structure as a tree and looks like a little tree. And that's important to know because our XML data is the same way. All right? In other words, now instead of being actual branches of trees, in the case of XML, it's node lists. So our XML document is a node list. There's a root node, and there's a list of nodes underneath it. Every tag in here forms its own little mini node list. All right? So for every tag on here, we can ask what its first child is. We can get its next sibling. All right? If we're going to use the analogy, if this is a child node, this node would be this guy's sibling, as would this node. So we have a set of functions built into the DOM. And let's look these up. I use this resource, but there's a lot of resources for this. There's a set of functions, and then there is a set of attributes or properties associated with it. One of them is the first child property. And the first child returns the first child node of the list. All right? I can then get the next sibling, and so on down and parse through it. Now, I can also use the get element by tag name. All right? And what will that return? That will return, again, another node list. So, if I say get element by tag name, I'm not returning back one node, I'm returning back a list of nodes. So if I, for example, were to say, x equals XML data, get element by tag name, get elements by tag name, first name, I would get a node list that contained every one of those first name tags. And then guess what? I could parse that node list if I wanted to. Now, first name is itself an elementary element. You don't go down any further. All right? But if instead of first name, let's say that was name, I could parse it to grab the first name, parse it to grab the middle initial, parse it to grab an alias of the person, parse it to, their birth name or whatever. All right? The idea is anytime I grab nodes, that's another node list. Just like anytime I chop a tree, it's a branch that looks like a tree. And I can then go and parse it or do whatever I need to. All right? So, there's a whole slew of functions associated with the DOM that allows us to do that. Functions and attributes. First child, there you can see some of them here. First child, last child. Node type, node value. Node value in the case of a tag will be null. In the case of a node like this, if I'm looking at this, if I said the node value of this node, it's going to be, or actually if I ask for the node value of this, it will tell me it's Nancy. If I ask for the node value of this node, it would give me null because, again, there's, it itself is a tag. All right? At any rate, really, ultimately, to parse levels deeper is just really more of the same of what we did. You just, with keeping in mind that once you parse and once you're pointing to a list of nodes, you can then parse that list of nodes using the same XML functions that we used before. Yes?
Would you do that? Why would you do that after you brought in a big list of whatever? Would you do that on the server or send back just what you? Why would you send this big glop of stuff you've got to parse through after you get it?
Well, okay, true. The question was, why would I send back a whole bunch of stuff and then parse through to grab only what I needed? Well, there's a couple possible explanations for that. One is I might be using a script that's used for a bunch of purposes, and my client may only need some of the data that it returns. All right, so I may use, for example, a potential example. Let's say, I have some relationship with Federal Express, my organization, and Federal Express gives me, if I follow a certain protocol, they may give me some XML data, and that XML data might have a lot of stuff in it, but maybe I only need some of it, in which case I can parse it and pluck out the stuff that I need. So that's one possibility. Another possibility is, even assuming you do need everything, you got to format it somehow, right? You have to take those fields. I'm talking about plucking a particular value out of the file, all right? But you may have to do that a bunch of times to accumulate all the data that you need to output something, something massive, all right? So yeah, it may only be returning the stuff that you need, but you still need to parse it to pull the stuff out so you can format the output and present it in a way that the client requires. So yeah, if you're talking about, you're writing a script that only you're going to use, all right, then yeah, you only return the data that you need, all right? But even in that scenario, the client still needs to parse it so that it can pull out the pieces and format it, as opposed to just raw dumping out the XML data. All right. Last thing I'd like to do before we get into our evaluation is look at the code for this, which spits out a list of employees. First of all, keep in mind this is part of an AJAX application, right? Therefore, we are returning back XML. Therefore, you'll notice at the beginning, I am outputting some header information that indicates that I'm indeed outputting XML. And again, in that way, your client program will know to grab that from the response XML as opposed to the response text. Now, this could be, if this was a traditional model, if this is a traditional client-server application, and maybe I was doing a query where I wanted all the employees whose titles match something, all right, I would output, not XML, but I'd output HTML or XHTML. And I would output the data in a similar way, except I wouldn't output the XML tags, but I would output the HTML tags with the data in the position that it needed to be. So like maybe if I wanted to make a table, instead of outputting an employees tag, I'd output a table tag. Instead of an employee tag, I'd output a TR tag. And instead of each of those tags, first name, last name, title, city, region, I'd output TD tags. So you can see that between the XML and a traditional client server doesn't have that different of a job. It's just the format of the data that it's outputting. I'm grabbing the title that I'm searching for from the query string. So it has to be in a field on the query string called title. I concatenate a $sign before and after it. That is because, again, the standard in SQL is that you use the $sign for the wildcard. All right? Those of you that maybe have used Access before know that Access uses an asterisk for wildcard. But this is going through ODBC, and therefore we use the standard, which is the $sign. I skipped a couple lines up here. I'm creating my connection equals ODBC connect. That's a built-in PHP function. And I'm supplying the parameters I need to connect to it, which is the name and possibly a username and password. For example, if I was using SQL Server, I'd probably have to supply a username and password. Remember that gets set up in my data sources, at least in Windows, under Administrative Tools. And I said my data source named Northwind maps to that Access data source. What's nice about this is if you do it this way, you can actually change even the type of database that you're using. You could take an Access database and convert it to SQL Server. And all you need to do is change that ODBC setting. It would no longer point to a Access database. You could point it to a SQL Server instance. All right, and do it that way, or Oracle, or MySQL, or anything. That's a nice thing about ODBC. It's roughly analogous to those of you that have done .NET of storing the database connection string stuff in the web config file. All right. The idea is one place to change it, and you're all set. ODBC, again, stands for Open Database Connectivity. It's sort of platform independent. So as long as your platform has a driver for the particular kind of database, an ODBC driver for it, you can connect to it. So even though you can't run Access on a Mac, let's say, or you can't run Access on Linux, all right, you can, if you have that driver, use it to connect a web application using ODBC to an Access database, or to an Access or any other type of database. So that's what this does. This connects to that database, again, using just the ODBC name. Again, notice nothing in there says what kind of database it is. Nothing in there talks about the physical path to it, right? And that's good, because we can change all those things without having to go back and change our application. We could change where the database is physically located. We could even change the type of database. Chances are, this kind of code might live in an include file that I would include in all of my pages that were going to interact with the database. If that connection has a value of false, it means something went wrong. It didn't connect. I grab the title. I format the SQL statement, part of it being hard-coded, part of it being filled in with my variable. This is standard in all sort of server-side languages that interact with the database. You're going to have a piece of your SQL statement that's hard-coded. Select star from employees, where title like, and then there's going to be a parameter that you fill in at runtime. I then go and execute that. I get the results in a record set. That's what $RS represents. I then loop through that record set and pluck out the different values. $fname equals ODBC result. Pull from the record set the thing called first name. Last name, title, city, region. I then output those XML tags, and when I'm finally done, I close my connection and close my XML data. All right. There'd be similar code for any sort of SQL that you do. With selects, it would be like this. With inserts, updates, or deletes, it would be similar to this. You don't get a record set with those, however. All right. And again, they all sort of follow the same sort of mold, where you have a SQL statement that is partly hard-coded and partly gets filled in at runtime. Any questions on this? Well, remember, you don't define RS, you don't define variables in PHP. You just start using them. This statement, ODBC exec, returns a record set.
Oh, okay.
And that record set, first of all, I can look to see if it got an error. Otherwise, I can loop through. That's what this while loop does. The record set's sort of like a sequential read. Every time you grab a value, you grab the next row that you haven't looked at yet. When you're all done and you've grabbed all the rows, you get a value of false back. So this will return a false if there's no more rows left. It will return a true as long as there are rows left. So the first time through, our first fetch rows grabs the first row of that record set and returns true. We do our thing, we loop, we retrieve the next one, and so on. At some point, when there aren't any rows to retrieve from that record set, this function returns a false, and our loop knows that we're at the end of the line. And we can pop out of the loop. All right. Other questions? Okay. I'm going to finish the recording of this, and then I'll set you folks up for the evaluation. I will pass it out, then I will be over in lab. Let me just call down there, tell them they can stop recording.